names like MD2 or XM1, then you're using the standard packaging. If your licenses are CAT, MCE or EDE, then you're using the PLM Express packaging. PLM Express packaging usually offers better value for money and is the way that most of the people are buying CATIA 5 these days. This presentation is to show you some of the features offered in specially priced add-ons. Some are for adding your PLM Express installation and some for your standard installation. For PLM Express, the special offers are for mechanical product creation, which is MCE, fabricated product creation, FPE, mechanical shape design, which is HDX, and for standard packaging we have sheet metal design 2, SMD, step core interface, ST1, and generative shape design. Very briefly, I want to show you what's offered in the base CAT PLM configuration, which a lot of users have access to. The foundation configuration for PLM Express CATIA is generally referred to as CAT. It includes part design 1, assembly design 1, wireframe and surface 1, generative drafting 2, and interactive drafting 1. It also contains the IGES and the step interface. These packages are available in two orientations. You have either the Team PLM or the CAT 3DX, which was formerly Inovia. While standard packaging doesn't have one foundation set of design tools, the comparable configuration would be something like CATIA Mechanical Design 1. This has all the CAT functionality except for step and doesn't come with a PDM system. PLM Express add-ons usually include more than one product, while the standard add-ons in this special offer are individual products. During the demonstration, I will try to make it clear which products you are seeing in action. Here's some of the features that MCE brings on top of those in the foundation CAT configuration. I will focus mainly on part design 2 and generative shape design 1. I will show you what FM1 offers as a different approach to solid model design using functional modeling. To ensure that we stay on time, I'm going to show you brief videos that we've recorded. Because there's likely to be a little bit of lag, I may have to pause the video every now and then. If you have any detailed questions on any of the functionality, then please contact us after the webinar. That way we can ensure to get complete understanding of what's being offered. We'll start with what's offered in the Sketcher. This is two new sketch profiles, porcupine curvature analysis, and edit multiple constraints. Since PLM Express CATIA comes with a 3D Experience PDM, I'll use this to create the new parts and save the parts later on. Firstly, we connect to the 3DX server, which in this case is running on a virtual machine. I'll then log on to collaborative space and select the role for this session. In this case, I want to start a new part document from a predefined template part. And I'll now get into showing you some of the added features available in PGG or GS1, which are part of the MCE package. Firstly, we have the additional closed profile. We have the keyhole profile. We also have the cylindrical elongated hole. It's also worth noting that since we're using R26 in this case, the automatic constraint options on in Sketch Tools, and we create considerably more dimensions than previously. We can also analyze the curvature of curves using the porcupine analysis. To show this, we'll replace the large arc with a spline and then apply the porcupine analysis. persistent, even after exiting the sketch, to remove the analysis, we would just apply the porcupine analysis again. The first and second limits of a pad can be changed by dragging the limb 1 and limb 2 tags within the 3D. And PDG allows to extrude in the direction, the pad in a direction of a line or vector, in addition to the default normal to profile. In addition to the basic surface-based features of thick and close, PDG offers sew surface, which fills in with a solid under the surface. This is more than a thick surface, as we'll demonstrate by sectioning the solid. PDG allows a multi-section solid with more than 2 profiles. With PD1, we can only create a solid with 2 profiles. With PDG, there is no limit to the number of profiles. With CATIA R25 and 26, we can select the vertex to create a fillet. And PDG adds the ability to adjust the setback along each edge of each of the edges converging on the vertex. With PDG, we get an additional Boolean operation. Just in case you need to know, the basic Boolean operations allow us to add 2 part bodies together, or subtract one from another, or intersect 2 part bodies, or even assemble. We now have the option of union trim, which is similar to add or assemble, but with the added advantage of being able to select faces on one of the bodies or both of the bodies to indicate that adjacent geometry should be removed. CAT comes with wireframe and surfacing 1, which offers a good set of basic surfacing tools, primarily intended to help you with the part design. GS1 provides some significantly more powerful surfacing functionalities, including filleting, spiral and helix, added sweeping options, and multi-section surface. GS1 surfacing fillet shape for surface, put my teeth in, filleting shape filleting, edge filleting and face-to-face filleting. As an example, you can see the edge filleting function, which provides both constant radius The helix function allows you to create a helix of a number of types with constant or variable pitch, clockwise or anti-clockwise. In a similar manner, we can create a spiral with controllable start and end radii, pitch and revolutions, etc. GS1 adds both automatic circle sweep and line sweep to CAT's explicit profile-only functions. To the explicit profile function is added relimitation and orientation controlling spine. The line sweep makes it quicker to create linear surfaces that are an angle to an initial surface. The circle spline uses a defining center curve and radius. With the additional spline capability, this lets you control the orientation of the circle plane as it sweeps along the center curve. GS1 also offers the multi-section surface through an unlimited number of profiles in a similar manner to the solid version. Functional modelling part, which is part of the MCE package, gives you a new way of creating solid parts. Instead of modelling all the geometry required for a feature, FM1 helps you to create features based on their function. Functions such as shellable feature, protective feature, etc. In this part of the demo, I will very briefly show you some of the concepts of functional modelling. In this short example, I will make a basic plastic body for the motor and a battery in the functional modelling workbench. First of all, we add a solid functional set. We start by adding a shellable feature. In this case, I'm going to create a pad from an existing sketch and create the integrated fillets. Note the finished pad doesn't look shelled. This can be edited later or before editing using the shell properties. I'll add a feature that acts as a rib and is functionally an internal feature. Note that despite the size of the sketch, the function of the feature is to be internal, so it stays internal to the shellable feature. I then pattern this feature and it will also stay internal. What I'm doing now is I've decided that there's space that needs to be reserved for the motor. I could have decided this before creating the ribbon pattern, but what I do now is create a protected body from the body that contains the motor geometry. In this case, I need a clearance of 3 mm all around the motor. except for the front face. The resulting protected space is shown in red, and I will then hide it. I will now add another pattern of ribs. Again, I use the internal feature. Note the protected area stays protected. I'll now add another sketch base pad for a protected area. And finally, I'll add another shellable feature based on a sketch. The fabricated product creation, FPE, contains two products. We have weld design, which we unfortunately don't really have time to demonstrate today, but I will demonstrate the sheet metal 2, which is SMD. SMD is generally used to create belt metal parts. I will show you some of the basic sheet metal design features. SMD can also do some doubly curved surface flattening. I want to create a sheet metal cradle for a car radio. I have a product with the car radio in it and an empty part for the cradle. I'll open this from the 3D Experience platform, the PDM, by searching for parts that start with the letters RAD. For the purpose of this demo, I'll show you some very simple folded sheet metal functions. Then to save a little bit of time, I'll load up the finished part and we'll just scroll through the tree. I'm going to open the sheet metal part document with an initial sketch in a new window. Initially, the sheet metal parameters will be set. This includes the thickness of the material, the bend radii, the default corner relief, and the bending K factor. I will create the first wall on the sketch. Since the thickness is already predefined, all I need to do is check the direction, or I could also apply an offset from the plane. I then create a few walls on edge where I can control the height of the wall, the left and right edge offsets, the angle, etc. Corner reliefs, if necessary, will be the default, or I can change them now or later. I can unfold and fold the part at any time to check the pattern. Maybe I want to add a feature that's best done while flat, such as a cutout that's going to span two walls. There are a large number of stamp features, plus the ability to define your own. I'm going to add a louver. And I'll now go back to the assembly and replace the sheet metal part with the completed one. I can then step you through the process. So starting with the initial wall, I added 4 more walls on edge and a sketch base cut out. Sometimes a flange is a good alternative to the wall on edge. And then fill it in some corners which are added to break the sharp edges. To create the overlapping riveted joint, I use a user-defined flange by sketching the profile I need. A few more cutouts and then a pattern to the U-shaped cutout. Then put a couple of holes in the riveted joint. Again, I can unfold to check that they went through the overlap okay. Then another louver, which I'm going to pattern. A few more flanges and walls on the sliding rail. And finally, a surface stamp as a locating indent. I can save the unfolded part directly to DXF, and I also want to check for any overlaps. I can also create a new drawing from one of my standard templates in the PLM system. I can create a flattened view without having to flatten it in 3D. HDX mechanical shape design consists of 3 products. We have Generative Shape Design 2, Freestyle Shape 1 and Developed Shapes. I'll start with the developed shapes. Although it's a separate product, it is accessed as an additional toolbar in the Generative Shape 2 design. It can be used to flatten either ruled or doubly curved surfaces. You can see a double curved surface which I'd like to flatten. I select the Unfold tool, select the required geometry, the default assumes that the surface is ruled and that is able to unfold without distortion. My surface obviously is not ruled, so I have to select all as the option. Although we don't have much control over the distortion, we can see where it is, but first we switch to the material view, and then we can select whether to show on the folded view, the unfolded view, or both. And the last thing I want to show you in this workbench is the ability to transfer wireframe geometry to and from the surfaces. In this case, I want to transfer the transfer sketch to the curved surface. The upside down result shows that I got the original orientation wrong, which I can correct now. Generative Shape Design 2 GSD offers additional features in a range of functions. I'll now briefly show you the sweep function and how it's expanded. The explicit sweep has a number of sub-options. Line sweep and circle sweep have many more options available. As an example, I'll use the two curves to create a circle sweep using two guide curves and a radius. Because there are 6 possible circular sweeps, we can get to pick which one we want. I'll now edit the sweep surface to show how the law option can be used. I'll define an S-type law so the radius varies smoothly from 20 to 50 millimeters. One of the new features offered in GSD is adaptive sweep, where the shape of the curve being swept can be changed as it is swept. This is not just scaled, but actually changed. I can select the guide curve, accept the defaults for the spine and reference, and use Adaptive Sweep's own sketch tool to create a position sketch. I can then define the sketch with the constraints that I may want to edit later. The default sweep keeps the dimensions the same, but it is different from the normal explicit sweep, which would scale the sketch along the curve. What I can do in Adaptive Sweep is to move the profile to the designated positions along the guide curve and then edit the parameters at each point. This gives me a lot of control over the shape of the final surface. Law gives me the ability to have control over the parametrics, etc. As a quick example, I'm going to create a parallel curve, which is a curve on a surface offset from another curve. In this case, this is a surface on a plane, and the starting curve is a circular arc. I'll use the built-in law function to start with, first a constant offset, then a linear varying offset, then cubically varying offset. Now I will create a law created from a trigonometric function. Here's the function I created shown bigger to see the sort of thing that you can create. And lastly, I can draw the law in a sketch. I can see from this sketch that I want the value to start at 16.716 and then vary as we move right along the sketch. I use the law function to convert the sketch into a law and then replace my mathematical law with a geometric one. You may have noticed earlier during the GS1 filleting the extruded surface was wrinkled. This was because the curve that created it was wrinkled. GSD offers a curve smoothing function to help deal with this problem. Curve smoothing offers a couple of different approaches to smoothing a curve. In fact, the curve is not smoothed, but a new smooth version is created. In this case, I'm aiming for curvature continuity and varying the amount of deviation from the original curve that I can tolerate in my design. I can control how the endpoints behave and display information on curve quality and discontinuity, etc. Once I have a smooth curve controlling the surface, I can then continue to modify it and control the surface quality. I can use the curve analysis tool like the porcupine at any time. The HDH add-on also includes Freestyle Shaper 1, which is essentially the introductory NURB surface and curve design product. This demo will only very briefly demonstrate some of the features. In this example, I want to edit an existing extruded surface in NURBS, a non-uniform rasterized basis spline. When I add control points to the surface, it creates a new matching NURB surface. This software shows the number of control points required to create the NURB surface. I can edit the number of control points in each edge to allow more control. With the control points panel, you can select how you want to modify the surface, either by selecting one or more control points or by selecting one or more rows of points. The movements of points can be normal to the surface, tangential to the surface, or along the initial plane. There are a number of ways of visualizing the surface quality. We'll look at some more of those later. You can also match one surface to another and control the edge constraints. We can also concatenate the surfaces together into a single NURB surface. We can extract a portion of the surface. And we can measure the distance between two surfaces through a set of distance vectors. And then here's some more of the visualization tools. There are many more tools for this package, but that concludes today's demonstration. So I will now hand you back to Mitch. I apologise for the delays in the video. I feel a bit like a DJ spinning decks here. We've got a few laptops going. I've tried to keep it flowing as much as possible. Thank you.
Thank you, Paul. Thank you guys for attending our webinar. We've recorded the webinar. Hopefully the lag will be less obvious in the recording. Please bear with us as the sales team will also be contacting you to follow up with any inquiries you have. Unfortunately, we've actually run out of time. Is there any quick questions now? You can actually type into the chat, or if not, you can just contact Sam, Max, Paul, or myself via email or call us on the phone, and we'll try to answer your inquiries as soon as possible. So there's no questions, so that concludes our webinar today. Thank you for attending.
Thank you.